Hello and good morning to everyone. In the last days, we have already done the discussion that which topics we are going to learn in our triangle chapter. So today we will do the discussion on the first topic of our triangle chapter, and the name of the topic it is similar figures. How we can say that the two figures are our similar. Before doing the discussion of the similarity of the two figures, I want to recall you the definition about our congruence. When we can say that the two figures are congruent. Listen, in one side I am writing congruence, and here it is another side I am writing it as the similar. Everyone, you just have to see, in the last class it was said to you two circles. This one it is one circle, this one it is another circle. Both the circles we can call it as the congruence whenever both of them having the same shape along with the same size. As this one it is a circle, this one it is the circle, 100% their shape it is same. But how we can say that the both of them having the same size? So for the size, its radius it must be same with its radius. Understood or not understood? Then after also it was said to you, suppose this one it is one of the equilateral triangle, and this one it is another equilateral triangle, and here it is its side is same as its side, its side is same as its side, its side it is also same as its side. So from the two triangles, actually both are the equilateral triangle. It means both of them having the same shape, and to have the same size, its side must be same as its side, this side same as this side, and this side is same as this side. So for which it was said both the equilateral triangles are our congruence. Understood or not understood? Then after also example of the square it was given, and both the square we can call it as the congruent whenever both the squares having the same sides. Actually why not angle? Because the angle, this angle 90 degree, already 90 degree, 90 degree, 90 degree, 90 degree, and here it is our side. Each of the sides are same with the each of the sides of the another square. So for which both the square we can call it as the both the squares are congruent to one another. So remember, to be congruence, both the figures must have the same shape along with the same size. It means two things it is to be followed. One, it is our same shape, another one it is our size. So here also few of the figures I am doing in comparing with the left side congruence figure. Then after you just have to say me which one it is the similarity between the two. See, here it is one circle, here it is another circle. So 100% by seeing we can call that 100% both the figures, their size it is not same. Their size it is not same. But one thing it is same between them, that one it is their shape. This one it is the circle, also this one it is the circle. Also another figure I am showing, this one it is also the circle. This one it is the circle, this one it is the circle. So the common thing amongst all the circle is their shape it is same, but their size vary from one another. Understood or not understood? Here I am showing you the another figure. See, here I am showing you the another figure. This one it is the equilateral triangle. You know that the equilateral triangle means each of the angle measure it is your 60 degree. Yes or no? And here it is another equilateral triangle I am showing. This one it is the equilateral triangle, this one it is also the another equilateral triangle. In both the equilateral triangle, one thing you just have to remember, that this one it is the equilateral triangle means angle same, its shape it is also same, its shape it is same with the its shape. But see, here it is, suppose here it is 5 centimeter, 5 centimeter, 5 centimeter, suppose, and this one it is 7 centimeter, 7 centimeter, 7 centimeter. It means it is sure, one thing it is sure, that both the figures having the same size, but they are sorry, both of them having the same shape, but they do not have the same size, because each side is different from its side different from its side, and its side is also different from this side. So for which here both the figures we can call that the figures having the same shape but do not have the same size. Here it is also the another figure I am showing. Suppose here it is 8, here it is 8, here it is 8, means centimeter, centimeter, centimeter. So from these three triangles, one thing it is clear that the three figures having the same shape but do not have the same size. Here also another figure I am showing. This one it is one of the square. This one it is another square. This one it is another square. This one it is another square. So from these four square, one thing it is clear that all the figures, otherwise all the square, all of them having the same shape, and the shape name it is our square, but they are varying whenever we will compare their size. This one it is the smaller, this one little bit greater, then after this one it is also greater in comparing to this one, and this one it is also the greatest one in size. Okay, so you just have to compare this figure with this figure. From this collection, all the shapes are same, shape to shapes are same, also size is same, shape same, size is same, shape same, and size is same. So for which all these pair of figures we can say it as the congruence. This one it is congruence, and this one it is congruence. Remember, whenever the figures having the same shape, whenever the figure having the same shape, not necessarily the same size, it means compulsorily they should have the same shape, not necessarily the same size. The size may be same, otherwise it may not be same. We are not demanding on the size, only our demand it is on the shape. If the figures having the same shape, see, this one circle, 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 all of them having the same shape, for which we can say all these figures are similar to one another. Understood or not understood? Perfectly understood or not understood? So it means only remember the definition of similarity is two or more than two figures are called as our similar whenever the figures having the same shape but not necessarily same size. Not necessarily, maybe same size, otherwise may not be same size. Clear? Here it is also the same. The shape it is same with one another, but the size differ from one another, for which all these triangles we can call them as the similar triangles. Here it is also all of them we can call it as the similar square, because their shapes are same but they are varying in comparison to their size. Perfectly understood? So this one it was our discussion regarding the similar of any of the figure. Another important thing I want to say to you, you just have to remember. See, here it is a congruence figure, here it is the similar figure. See, here it is a congruence means both of them having the same shape and same size. But I want it to be similar, I want only the shape. Only the shape it is our important one. Then after this one it is our optional. Which one it is our optional? Optional it is our size. Size it is our optional. So for which I want to show you here whether the congruence figure are our similar or not. Whether the congruence figures are our similar or not. Listen, one thing you just have to remember, whenever I am checking this figure, here I found that both the figures having the same shape and same size. But I want only the shape. This one it is our optional. So for which directly I want to check it is the similar or not. By getting the only shape, I can say that yes, this figure it is our similar. Another one also I am checking here, both the figures having the same shape, also the same size. But I want only the shape. as I got the shape, it is same. So for which also I can say that yes, the two congruence figures are our similar. Here it is also the same thing. Whenever I am getting the two figures having the same shape, also the same size, but we have the transaction with our shape. So for which we can say by checking the shape related thing, our shape is same. It means 100% these two figures are our similar. So it means one thing it is clear and one thing it is confirmed that every congruence figure, remember, congruence figures are similar. Congruence figures are similar. So it is one of the question it may be asked at anywhere, that whether the congruence figures are our similar or not. So your answer should be yes, always. The congruence figure always will be similar. Another means converse one we are checking. Converse one means our congruence is similar. So now we have to check whether the similarity is our congruence or not. See, here it is suppose two figures are similar. Suppose two figures are similar. But I want to check whether the two figures are our congruence or not. To be congruent, the figure must have the same shape, also the same size. But here it is clearly it is seen that the both of them having the same shape, but not the same size. So for which these similar figures are not congruent. So one may say that, sir, this one it is seen that both of them having the same shape and same size. So it means some cases, means sometimes the similar figure may be our congruence, but not always. Understood or not understood? So for which you just have to remember similar figures may be or otherwise may not be congruence. Otherwise sometimes means the situation it is just like this. Whenever it is look like same. Okay, so for which you are answering one point you just have to remember similar figures are not congruence always. Otherwise only congruence it means also always. Is it clear to everyone? So now we will do the discussion regarding the similar of our polygon. First we have already done the discussion of our similar figures. Now we will give our discussion particularly to polygon. Thereafter particularly we will give the specification towards our triangle. Okay. So from the larger means now we are doing the discussion from the figure, then after polygon, then after particularly we will do the discussion of the triangle. Okay. So now I am erasing this one. Next point it is to be discussed that one it is our similar polygon. So this one it is our similar polygon. Remember, whenever one of the picture I am giving it to the studio man and I am making that, you have to magnify it. You just have to magnify it. And whenever the cameraman, otherwise the studio man is magnifying, so one thing it is clear that always you have to see the angle between the any of the line, it will always be same. Suppose this angle I am comparing to this angle, you can find the corresponding angles are always same. This angle also same as this angle. This angle it is also same as this angle. Also this angle also it is same as this angle. Understood or not understood? Always you find that the corresponding angles between the two polygon, always it will be same. And another thing you will find, suppose this one it is your 2 and whenever you are magnifying, suppose it is 4 and suppose this one it is our 3. Just see one thing, whenever the length becomes double, 100% the breadth becomes double. So it means the corresponding sides change in a perfect ratio. It means corresponding sides also increase in the same ratio, otherwise maybe decrease in the same ratio. So here the ratio how much we are getting, 2 divided by 4. It means it is our 1 by 2. In the same way the breadth also it maintains the same, which it is also our 1 by 2. Suppose any of the another figure I am doing, any of the another figure I am also doing. See, just see. Suppose it is a suppose this figure I am giving that I want this figure, I want the similar figure of this one, I want the similar figure of this one, I want the similar figure but a little bit zoom in size. Okay, similar figure but I want to zoom. So always you can check that, always you will find that the corresponding angle, this angle 100% it is same as this angle 100% same as this angle 100% same as this angle 100% same as this angle it is same as this angle. So it means the corresponding angles of both the figures 100% it will be same. Corresponding angles are 100% same. And another one it is, whenever I am comparing this side with that side, always see, suppose it is 2, it is 2, it is 4, it is 2, it is 2. Suppose I am zooming and I am getting it as the, suppose this one it is our, suppose here it is 2, suppose here I am getting it as the 6. It means I got it as the 3 times. Here it is 100%, it will also be 3 times. 100% it will be 3 times. 100% it will be 3 times. 100% this one it will be 3 times. So for which to be similar means the polygon to be similar, corresponding sides are equal and corresponding angles are equal, and corresponding sides their ratio it will always be same. Otherwise one can say that the sides are in proportionate, otherwise same proportion. See, here it is 2 divided by 6. How much? Here 2 divided by 6. How much? Here 4 divided by 12, also that much. This side 2 by 6, also that side also 2 by 6. And you just have to remember, and here it is the ratio. Here this ratio, it is calling this ratio 2 by 6, it is also 1 by 3. This one it is also 1 by 3. This one it is also 1 by 3. This one it is also 1 by 3. So togetherly all the ratio, its simplest form it will be our 1 by 3. So for which the ratio between their corresponding sides it is called as our scale factor. It is called as our scale factor. So remember one thing, to be similar, the polygon to be similar, first criteria it is to be satisfied that corresponding angles are same, and next one it is our corresponding sides are in same ratio, or same ratio means proportion. Understood or not understood? So the two things it was taught to you on today. One, it is our similar figures, and it was said to be similar, the figure must have the same shape but not necessarily the same size. So whenever particularly we did the discussion of our polygon, and it was said to you that the corresponding angles are same and corresponding sides are in the same ratio, otherwise in the proportion. Also, one of the important point it was said to you that the congruence figures are similar, but similar figures are not necessarily congruent. Understood or not understood? Whatever the thing we have already learned, all these things we have to apply to do the question of the first exercise. Thank you. Have a beautiful day ahead.